So since two composition ranges, overall mixture composition ranges are given where a two-phase mixture can exist, it implies that an azeotrope must be present. So if it's a high pressure azeotrope, let's say that would be the value of the pressure, it implies that in that first range, the lower value corresponds to x1, whereas the higher value corresponds to y1. In the higher composition range, the lower value will correspond to y1 and the higher value to x1. So the opposite is then true if a low pressure, let's just choose a pressure that will be viable, that a low pressure azeotrope exists, the lower value in the first range would correspond to a mole fraction in the vapor, higher value corresponds to a mole fraction in the liquid. The higher end, this would then be x, and the higher value would correspond to y. But now you are expected to know that repulsive forces will result in a high pressure azeotrope. If you're still unsure about that theory, please consult the relevant section in Smith, Van Ness and Abbott. So we are asked to calculate this value, the pressure value, where this behavior will be observed. So you will notice, if you want to start doing those calculations, that the parameter in the activity coefficient models are not given. So we have two unknowns, and therefore we have to set up two equations to solve them simultaneously. There are various options. The one I used is to say, let me apply Rolle's law in the low concentration range, so I know what my value of the mole fraction in the vapor phase is. The pressure is the unknown I want to calculate. I know the value of x. I can write my activity coefficient equation in terms of that value of x1, and I know the value of the saturation pressure. So I've got my two unknowns in that equation. I can apply the equation once more, but to this high composition range. So now I know the value of y corresponds to this lower value in that range, and x corresponds to the higher value in that range. And I can now set up the same equation, and your clever calculators can solve for this parameter A and the pressure, which is the answer that is actually required in this problem.